Assalamualaikum warahmatullahi wabarakatuh. My name is Bela Lisfatia from Robotics B Morning. In this video, I will explain the computer vision course assignment on vision language model, which is searched from Jovana Mitrovic in YouTube. Vision language model learn from images and text simultaneously in order to solve different tasks including classification, visual question answering, image captioning, and more, so that it takes both these modalities and input and generate in speech. So, why are VLM very important in the field of AI and computer vision? VLM is a type of artificial intelligence model that utilizes the ability of computer to process visual and text data using the field of computer vision. This makes VLM very important in both fields to produce a deeper integration between visual data and text-based information. So, how vision language model work? Based on this picture, VLM combines image encoder and text encoder by using dual encoder-based approach that is responsible for generating encode visual and text feature representation. Dual encoders are one of the common architecture in VLM used for alignment between visual and text modalities. The loss function then align the representation from both encoders to be trained together in one training stage. And how vision language model work for the model? The clip is one of model for the VLM. That clip is contrastive language image pre-training is a multimodal model that learns the correspondence between natural language and image. For training use clip for VLM, we make to use some of specification like use large dataset of web scrape image text pairs around 400 million pairs and then classify which caption belongs to which image, learn both encoder from scratch and then train with large base sizes. And this picture is an architecture of clip and how it's trained. The model architecture consists of two encoder model. There are text prompt and images. The text prompt use the transformer model while the images use the ResNet or vision transformer. And then after that, the text prompt and the images will learn linear transformation from feature to embeddings. And finally, maximize the cosine similarity for each pair of text and image embeddings and minimize for false ones. And once the model is trained, it can be used to perform object classification on image. And clip summary have advantages and challenges. For the advantages, first is new paradigm for training and evaluating visual representation using language such as simple model and objective, unimodal representation in shared latent space, open vocabulary classification, and enable open vocabulary vision tags. The second advantage is successful trade-off between scale plus variety of data versus noise. For the challenges, first is scan level alignment between text and image. Granularity of caption has significant influence on what gets extracted from image. Second is pair data needed. Third is contrastive loss requires whole batch for single data point loss calculation. And the last is prompt engineering is important. And the application and outlook from the VLM, one of the applications is robotics that understand visual textual instruction. Robot using VLM for visual textual understanding often use dual encoders as one of the basic architecture in their system. Based on this video, the visual encoder used the process visual data, image or video from the robot's camera, while the text encoder is used to process language input from the user and capture through a microphone or microphone module on embedded board. Then the robot perform navigation based on the language input involving language comprehension, visual analysis, multimodal integration, path planning, and navigation execution. The visual encoder processes data from the robot, camera, or sensor to understand the environment using deep learning model like YOLO or faster RCNN for instruction relevant object detection. Then the robot integrates text and visual representation to determine the target location. Example of this application can be used in warehouse robot, home assistant, and etc. Vision language model have a development potential and future challenges. For the development potential, VLM have great potential to support more intuitive human-machine interaction with the ability to understand and integrate visual data as well as text in various applications such as robotics, education, and autonomous vehicles. For the challenges, the main challenges of VLM are the need for high-quality pair data for training, as well as ensure accurate alignment between visual and text modalities in complex environments. So, is this technology promising? In my opinion, VLM technology can be promising, but it can also be a threat. If this technology is used for the benefit of simplifying complex tasks between human and machine in various fields, it is very promising. However, if misused, this technology can become a threat such as manipulating visual text context to spread false information or privacy violation. Therefore, VLM technology should be utilized responsibly and bring positive benefit to society. And the last is summary for the VLM. First is vision language model process visual and text data simultaneously. VLM can increase the flexibility to handle large-scale data and data variation. The third is a dual encoder architecture is used to align visual and text representation using a loss function to be trained simultaneously. Fourth is one of the VLM model is CLIP or contrastive language image pre-training, requires a large dataset of about 400 million pairs, skin level alignment between text and image, and optimization for real-world environment. The last is VLM can be implemented into various sectors including education, medical, industry, robotic, and various case studies in the use of social media content detection, text-based image search, automatic captioning of image or illustration, and etc. And then that's all my explanation. I apologize if there is a mistake. Wassalamualaikum warahmatullahi wabarakatuh.